We're back now at question number 11, and I will say that number 11 is probably the hardest question on this whole paper. And one problem is that we haven't really learned how to do this yet. So you're just kind of guessing and playing with numbers and hoping that you get it right. But let's read the question and see if we can at least understand the scenario behind it. It says an object is launched at 19.6 meters per second from a 58.8 meter tall platform. So here's what that kind of looks like. You, let's pretend you, are standing on a balcony at, let's say, your house. Okay, so there you're standing on your balcony at your house, and it says that your balcony is 58.8 meters off the ground. This is the platform, okay? Now it says that you're going to launch or throw an object off the platform, and when you throw, most people throw things up in the air, and then it comes down and it hits the ground somewhere, splat. That's usually what happens. It says here that the object is launched 19.6 meters per second from a 58.8 meter tall platform, okay? So here's our job. The equation for the object's height, s, at time t is the following. Function s of t equals negative 4.9 t squared plus 19.6 t plus 58.8. Now at this point I'm hoping you have a calculator because these decimals are not going to be fun. So here's our objective. When does the object strike the ground? When does the object strike the ground? So let me draw a background picture here and see if you kind of understand how this works. This particular thing, if I were to have continued it, should remind you of a parabola. And in the parabola world, you can actually graph the parabola. This thing here on the side is going to be your height. This thing down here on the bottom is going to be the time. So remember it said height was t and time was s, okay? So right here at the center, that's 0. That's when you threw the ball. Right here at 0, you hit the y-intercept right there at 58.80. That's your y-intercept. Now our job is to figure what time, this thing here on the bottom, what time will it hit the ground? Now when it hits the ground, doesn't x have to be 0? Well, no, x doesn't have to be 0. X is going to be something else, but y is going to be 0 when that thing hits the ground. So we need to figure out what x could be if y is going to be 0. So do you see this equation? What have we said before about this function name, s of t or f of x? Doesn't this thing actually end up equaling y? And what did we just say y needed to be? Y needs to be a 0. So the question is, what could letter T be so that it would equal 0? Now think of you throwing a ball. Does the ball stay in the air very long, or are we talking just seconds, right? So you could try the number 1 in all these spots and see if you could get to 0. Try the number 2, try the number 3. See how long it takes you to create the number 0. And from there, that's the best guess that you could get. Okay, so all I'm going to do is suggest that you plug in numbers to get it to equal 0. That's your goal. Now we'll be back for more with a calculator because unfortunately I can't do this problem without a calculator. Too many decimals, too many things going on. But I could tell you that this right here is going to have to create a negative 58.8 somehow so that it will add to that 58.8 and create a 0. So what could we multiply to t to do that? Well, t is going to get squared. Let's say it's a 2, 2 squared 4, that's not going to make a big number. How about we say a 5? 5 squared is 25, that's going to make a much bigger number. So I would suggest jumping up here into the 5 range and seeing if 5 is going to work first. If 5 doesn't work, try 6. If 6 is too much, try 5.5. There could be decimals in this problem as well. So good luck to you. We're going to leave you at number 11 and head quickly to problem number 12. Number 12 and number 13 talk about rate of change. Rate of change. A climber is on a hike. After 2 hours, he is at an altitude of 400 feet. So after 2 hours, he is at an altitude of 400 feet. Do you see how we wrote that little fraction? Now it describes him 6 hours later. After 6 hours, he's at 700 feet. 6 hours, he's at 700 feet. Rate of change is a fancy word for slope. We need to find the slope between these two guys. Okay, so how are we going to do this? Well, this could almost be considered a point. You went over 2, you went up 400. You went over 6, you went up 700. These are points. From these points, can we use our x1, y1, x2, y2? Let's use our slope formula. y1 is 400, y2 is 700, x1 is 2, x2 is 6. What is 400 take away 700? Negative 300. What is 2 take away 6? Negative 4. Well, the two negatives are going to cancel. I could leave my answer as 300 over 4, but do you remember us talking about how rate of change always had to be out of 1? So I'm going to take that 4 and I'm going to divide everybody by 4 and see what I end up with. So the 1 on the bottom, 4 goes into 37 times, leaving you with 28. 28 carries the 2 down, leaving you with 5. Your answer is going to be 75 feet per hour. That's what your rate of change is going to be. Remember, it has to be out of 1. So that brings us then to question 13. Number 13 is almost the same question, but with different numbers, and you got to be super careful with the whole negatives on this one. For this one, it says a scuba diver is 30 feet below sea level. Wouldn't below sea level be a negative 30? Then it says he was underwater for 10 seconds. So I'm going to put 10 seconds. Couldn't that be a point? 10 seconds, negative 30, that's your point. Then it describes a second scenario, 100 feet below water, 100 feet below water, and he was under for 40 seconds. So what would that point look like? That point would be 40 and negative 100. Now we have to plug it into our slope formula. So negative 30 take away negative 100 over 10 take away 40. Well, negative 30 plus 100 is a positive 70. 10 take away 40 is a negative 30. And if I divide it correctly, I end up with negative 2.3 repeating. 2.3 repeating. 2.3 repeating what? Feet per second. That would be your answer. And remember, it has to be out of 1. So we were literally dividing the top and the bottom by 30 just so we could get that decimal. Okay, so that's problem number 13. Again, come back in just a few minutes and we'll hit up on problem number 14.